Hello and welcome to modeling using variation. So direct variation, this is where one variable increases, the other does so at the same rate. So to give an example of that, when you swim underwater, the pressure in your ears depends on the depth at which you are swimming. In the model, P is equal to 0.43 times D. P is the water pressure in pounds per inch, and at a depth of D feet. So at 10 feet, we could do P is equal to 0.43 times 10 to get 4.3 pounds per inch. The pressure in your ears varies directly as your depth, and this is an equation of variation, right? So direct variation is if a situation is described by an equation in the form of y is equal to k times x, with k being a non-zero constant, then y varies directly as x, or y is directly proportional to x. K is the constant of proportionality, and this is referred to as a special case of our linear equation formula, y is equal to mx plus b. So if y varies directly as x, and y is equal to 3 when x is equal to 5, we want to find y when x is 60. So this will be 3 is equal to 5 times k. We need to find k before we can actually find that value of y. So dividing by 5. Unfortunately, it doesn't really give us much of anything simplified, but we get a k value of 3/5. So to actually solve for y, we do y is equal to 3/5 times 60, which would give us a value of 36. So the general procedure for these things, to first translate whatever sentence or sentences that we have into algebra. Then substitute the given values to find the constant of variation, which is k. Substitute k into your translated equation, and then solve it. So another type is y varies directly as the nth power of x if there exists some non-zero constant k, such that y is equal to k times x to the nth power. We can say that y is directly proportional to the nth power of x. So for example, if y varies directly as the square of x, and y is equal to 18 when x is 3, we want to find y when x is equal to 10. So this will be 18 is equal to k times 3 squared, or 9. And when we divide both sides by that 9, we get a k value of exactly 2. So to find the value for y, we do y is equal to 2 times 10 squared. So 2 times 100, or just 200. And for example 3, I have a force of 60 pounds is needed to stretch a spring 4 inches. We want to know what force is required to stretch the spring 9 inches if the distance that a spring will stretch varies directly as the force applied to the spring. So we first do 60 is equal to k times 4. Dividing by this 4 gives us a k value of 15. So y is equal to 15 times 9. And that will give us 135 pounds. And then for b, I have the distance that a spring will stretch varies directly as the square of the force applied to the spring. So again, we do 60 is equal to k times 4 squared. So we would divide both sides by 4 squared, which is 16. This one, we could reduce a little bit. 60 divided by 16 reduced is 15/4. So y would be 15/4 times 9 squared, or 81. And this would give us about 303.75. pounds. So that's part 1 of this variation lesson. Be on the lookout for part 2. Let me know if you have any questions or concerns. Thank you.